Hey everyone, so it is time for the third review quiz for Module 1 in Canvas. Please do not watch this video until after you have taken the Slope-Intercept Form Review Quiz 3. This is to review things you got incorrect. This is not to watch beforehand. So, again, hopefully, please don't cheat yourself. I have noticed a couple of you have. There's no way that you magically got 12 right after all year long. You have had a hard time getting higher than an 80 on a test. It is normal to get 2 or 3 or 4 of these wrong. Don't stress about that. What's not normal is to get all of them right if that is not something that you consistently do. For a couple of you, that does make sense. But don't fake anybody here. You're not faking me and you're not faking yourself. All right, so here we go. So this first question here is actually kind of tricky because it's hard to figure out what information you need to solve the problem. So one of the things that you should do when you're faced with a problem that's kind of confusing is look at the answer choices. Well, when I look here, all of them are equations in slope-intercept form. So I know in some way I need to find a slope and I need to find a y-intercept. So I go here and I try to see maybe that information is just given to me in the problem. Maybe they give me a starting value, then maybe they tell me how much it changes by. So I read through here, and that is in fact not the case. But what they do give me is this piece of information here and this piece of information here. Well, that is two ordered pairs. And if I have two ordered pairs, I can find the slope. So what I'm going to do is I'm going to write this first ordered pair of 249. Now, important note here, 2 refers to a time. It's a number of hours here. So time is always, always, always going to be your x value. Every single time, always. Because time is always increasing. We know that x coordinates are always increasing as we read a graph. So time is always going to be your x coordinate. So at this point, I have two ordered pairs. That gives me enough information to find the slope. So I've got x1, y1, x2, y2. So that's going to be 39 minus 49 over 6 minus 2. Well, 39 minus 49, and I'm taking away more than I started with, so I'm going to get a negative. That's going to be negative 10. And then 6 minus 2 is 4. Well, each of these is divisible by 2. So that's going to turn into negative 5 over 2. So I'm at negative 5 over 2. So that is negative 2.5. So that is going to be my slope. So I go to my options here. Can't be that one because I know that my slope is attached to my x there. And so it's one of these two here. So now I need a y-intercept. So I know that the way to find that y-intercept is to write y equals mx plus b. I need a slope and I need an x and a y, so that's a point. Well, this is my slope. This can be an x and a y, or this can be an x and a y. So I'm going to continue along here, and I'm going to use my first ordered pair. So I'm going to use a y value of 49 is equal to negative 2.5, that's my slope, times x. Well, when I'm using 49, my x has to be 2 plus b. So this is going to be 49 is equal to negative 5 plus b. So I'm going to add 5 here to make that go to 0. I'm going to add 5 there to make that go to 0. Nope, to balance the equation, and that's going to give me 54 is equal to b. So I know that my slope is always attached to my variable, so that's negative 2.5x, and then my y-intercept's positive 54, so that's plus 54, and that is going to give us answer choice A. All right, so in the next problem here, we have a graph, and we almost always, when we look at a graph, they're going to be asking us something about slope or slope and y-intercept. So let's go ahead and look at our answer choices. It's asking us about fee and cost per hour. Well, that phrase per hour should be telling every single one of you that we are thinking about hopefully you filled it in, that is a slope. So I'm going to write the word slope right here. I know I'm going to need a slope. So all of these two are the same. So if I find the slope, I'd be able to cross out two of them. Let's think about what the fee is. Well, the fee is going to be the cost when there's no time used. So I'm going to go to when the number of hours is 0, and I'm going to look along my y-axis, and my y-intercept is there at 150. So something to explain there, this little jagged line is basically saying that like all of the numbers 0 through 149 are like smushed in that little space there because none of the data exists there. And the reason is because in order to rent the space, it costs $150. So there's not going to be any cost that's lower than 150. So rather than writing out all those numbers and starting the graph like way up here, they put all the data right in that little space. So now I'm going to just grab another ordered pair. So maybe that one just to verify the slopes because that's what good mathematicians do. So that's 0, 150, and 2, 210. So that's going to be 210 minus 150 over 2 minus 0. That's going to give us 60 over 2. It's going to be a slope of 30. So we already know that our y-intercept is 150 and our slope is 30. That could be B, that could be M. All right. So y-intercept to 150. Okay, we only have one option. It's got to be A. Slope at 30. Well, it could have been one of these, but since our y-intercept is 150, it is answer choice A. All right, so this question is one that makes you think a little bit, but if you really think about what this equation means, it's not that hard. So right here we have a value of x and we have a value of y. And it tells us, asking us specific things about the value of x. So that's weird. So let's go think about this equation and what x is. So it says that x is its age in weeks. So this is age in weeks. Oh no, this little pen is so ridiculous. Age in weeks. Okay. So our y value is the weight of something. All right. So basically this says something starts at 4 pounds and each week it's gaining 6/10 of a pound. All right. So what are we talking about? We are talking about a puppy. All right. So we all know what a puppy is. They're precious. They prance around. They snuggle. Oh my God, they're the best. So, and if you don't like puppies, don't ever tell anyone that because that just doesn't even make sense. They're so cute. Okay, so puppies. So, something else we know about puppies is they start really, really cute and they sleep in your little lap because they're so little. And then time passes, and very, very quickly, that precious little puppy becomes very, very large. However, that little puppy does not continue to grow for the rest of its life because, as do most things, it gets to its like maximum size and then it stops growing. So this is not like I don't know. When I was little, there was like books and like a show about Clifford, who was that massive red dog that was like bigger than a house. This is not like that. Like this is like a real puppy. So real puppies start really little and then they grow as weeks pass. So basically, let's go figure out what we're talking about. So this is asking us about the number 50 specifically. So let's go figure out what 50 is. So x is the number of weeks. So 50. Let's take that 50 weeks. Well, that doesn't mean a whole lot to me. So let's figure out how many years that is. Well, some of us know that there are 32 weeks in a year. No, that's not right. There are 52 weeks in a year. Is that real? How many weeks are in a year? 52. Definitely 52. So there are 52 weeks in a year. So in order to figure out how long this is, we're going to have to divide here. So I'm going to take that 50, I'm going to divide it by 52, and I get that this is 0.960, the blah, 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 blah of a year. So this is about a year. And that makes sense because most dogs really do only grow for the first years of their lives. So basically, this is an equation talking about how size increases, and then our x value talks about the number of weeks. So let's look at our answer choices. The first one's telling us that the model will probably work best for x values greater than 50. So that one suggests that the puppy is only going to start growing once the puppy is 50 weeks old or almost a year old, and that doesn't make sense. So we're going to go ahead and eliminate that one. The next one says the model will probably work best for x values of less than 50. So that actually does make sense because we're thinking about like the earlier weeks of its life throughout that first year. So let's go ahead and say maybe on that one. So the next one says the model will probably work best for whole number values of x. So this is a good one to explore. So let's think about what X means. So X is its age in weeks. So 1 week, 2 weeks, 3 weeks. And so you want to think in terms of whole numbers. That would suggest that time only exists in that like whole, or that the quantity only exists in that whole iteration. So if we're talking about weeks, we're saying that like there's no such thing as 1.5 weeks. Well, our answer choice C says there's no such thing as 1.5 weeks. Well, there is. That's a week and a half. And it is possible for the puppy to weigh a different thing on Monday than it does on Thursday because it's growing constantly. It's not like every Thursday and every Thursday at 8 a.m., the puppy gains 6/10 of an ounce. Like the puppy is gradually gaining that weight. So it doesn't make sense to only use whole numbers. So answer choice C does not make sense here. So D says the model will probably work best for negative values of x. So that's saying when our time is negative, that doesn't make sense at all. Time can't be negative. So that leaves us with B as our best choice, which does make sense because this growth equation for how the puppy is getting bigger does make sense for the earlier part of its life, which would be when its number of weeks are 0 weeks up through 50 weeks. All right, so this one is a little bit tricky just because of the wording, but you can absolutely do this. So in this question here, we're looking at a situation where we've got some triangles. And we know that they're trying to find the slope of the line from LQ, so the diagonal. That makes sense. All right, so I'm going to go be thinking about this here, each one of these, right? Well, the thing is that we know that the slope of a line is the change in what hopefully you have already filled in. It is the change in y, which is the vertical over the change in x, which is the horizontal. Because what you're going to notice here is that if we're trying to find the slope of this line here, the change in this and the change in this, which are both changes in y, they're both verticals, are the same as this change in x and this change in x, which are your horizontal values. So I'm going to go in here and I'm going to look at my values here for my change in y. So my change in y is this piece right here. Well, I notice that my line is going down. My change in y is negative. It's going from 2 down to 0. So this here is a value of negative 2. Then I go to my other vertical and it is here and it is going down to that point here, which we don't actually know yet, but we know that that is going to have to be negative 2 there. So, and this value here is, since it's 0 to y, we know that value is actually going to be the value of y. Because if I'm going from 0 to this value on the y-axis, that increase is y. And we know actually it's going to be a decrease of negative 2. So let's go figure out what else we know in this problem. And again, guys, this is a very tricky question, so just be paying attention as we go through it. So now I'm going to be looking here at my changes in x. So my changes in x here, well, I know here I'm going from 0 to x on the x-axis. So all I really have there is x. Like that change is the value of x. If it's going from 0 up to x, it is x. Well, here, my horizontal right here is going from -4 up here to 0. So that has to be a value of 4. So it's asking me what proportion I should set up to find that slope right there. Well, I know it's going to be change in y over change in x. Well, if I look here, my change in y is -2, and my change in x is 4. So I'm going to go look at my options here. And first of all of them do have y over x, so that makes sense. And if I go look at my values here, I want to be able to figure out my rise over run. And it is absolutely fine that the negatives are in different positions. But what you need to have is a value that's going to simplify to 1/2. So that is going to be answer choice A. Anytime there's a question where there's a lot of information in the answer choices, please read them and figure out what you have to figure out. So it is asking us about the rates of change. Let's see if they need specifics. What do they need? Positive, negative, no difference, greater, greater. Okay, so we actually need to know the actual rates of change here. So let's go ahead and figure those out. Well, rate of change is the same as slope. This is very easy in the first one because when I look at that, I already know where the slope is in the equation. I know that the slope is always attached to the variable, so the slope of this one is +2. When I go to the table, I'm going to find the slope. I'm going to use my positive points, 115 to 21. That's going to be 21 minus 15 over 2 minus 1. Well, 21 minus 15 is 6 over 1, so that one's going to be +6. So they're both positive. One of them's 2, one of them's 6. This one is function 1. This one is function 2. All right, let's look at our answer choices. D says there's no difference. There is a difference. They're not the same number. It says one of them has a positive rate of change, the other is a negative. That's not true. They're both positive. All right. It says the rate of change for function 2 is greater than the rate of change for function 1. Well, 6 is greater than 2, so chances are this is our correct answer. Let's verify. It says the rate of change for function 1 is greater than the rate of change for function 2. No, so that leaves us with answer choice B. All right, so here we go. So it says a restaurant makes deliveries, plotted data points on a scatter plot showing the relationship between the miles driven and the point of delivery. So, between the miles driven between the restaurant and the point of delivery. And then Y is the number of minutes between the time the order is placed and the time it is delivered. So let's go ahead and figure this out. So basically that means that the Y value here represents the number of minutes between the order placed and the delivery. So, and it measures time, or the amount of time that passes. So then, and I know that's confusing because that's a Y value that measures time, but X is also time. So that you're good. So it says X is the number of miles between the restaurant and point of delivery. Oh, that's not really time. That's interesting. So it's the number of miles between the restaurant and the point of delivery. So this is the miles. All right. And it wants to know, and it says that this is the line for this situation. So let's go ahead and figure out what we have here. So this is a scatter plot. So we know that the data is, there's going to be some kind of pattern, but it's going to be like kind of spread out. It's not going to be a perfect fit. And what does make sense here is you place a delivery call, right? So this is the miles from the restaurant, and this is the total time. And that's because the time here depends on the time associated with being a certain number of miles from the restaurant. So you place a call. The minute you place the call, you some amount of time. It's going to take them some amount of time to make your food, right? And then the further you are away, the longer it's going to take you to end up getting your food, because like they take some amount of time to make your food, and that's that amount of time. And then if you're standing right there, they give it to you and you leave. Well, if you are not standing right there, they have to travel to get to you. And it's saying that for each mile that you are away from the restaurant, you have to add another 2 minutes to the time it takes to get you the food. So I hope that helps you understand what's happening there. So it says the y value for each of the data points on the plot was 2x plus 6. And that one's trying to trick you into thinking they all have to be exactly on the line, and that's not true in this question. It's a scatter plot. B says the time of delivery for the next order can be found by evaluating the expression 2x plus 6. We also can't really use this to figure out the time of delivery specifically, because we don't know how far they are away yet. And again, this is used to make a prediction. It says it takes the restaurant about 6 minutes to prepare each order for delivery. So that would indicate that after 6 minutes, this whole process of the time increasing starts. And that actually is true based on this situation. So let's keep looking. It says it takes the restaurant about 2 minutes to prepare each order for delivery. Well, if that was true, that this process would start after 2 minutes and then it would be increasing. And that's not what's happening, so it can't be D. So here it is, answer choice C. So again, to clarify why, so this is a line of best fit, and I want you to remember the lines of best fit are those things that we created by going into our calculators and putting things in L1 and L2 and then running stat, blah, 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 right? So remember, those were scatter plots. Those weren't perfect linear equations, so they were estimations, and that's why it's not A or B, because those would be if this were like a specific, always perfect linear relationship. So I hope that helps there. And let's move on to the next one. Oh, one more thing. Another key word for answer choices about scatter plots is this word about, because that is indicating that you understand that there are estimations, approximations being made here. So you're going to see when we go into the scatter plots module, you're going to see like trick answers. They're like, it takes exactly this amount of time. Well, no, you won't know that because it's an estimation. So the word about is going to be a good one to think about when we're looking at scatter plots. All right, number 25 is again about two people. So we have to remember to read the questions carefully. Don't just look at this and be like, oh my gosh, it's a graph. There's two people here. We're talking about Sasha. We're also talking about Natalia. So if you're not thinking here, you're going to do ridiculous things. So the first thing that we know is that Sasha's information is given to us in this situation. It started with $170, and after 10 weeks, she had $290. So for Sasha, we know already her, well, think about it. Do you know her slope or her initial value? Hopefully, you know that you know her initial value here because it says she started with 170. So it's going to be y is equal to something times x plus 170. So in order to get a slope, you need two ordered pairs. So an important thing to recognize is this 170 can be written as an ordered pair. So that's going to be 0, 1, 70. Then the second ordered pair we have here is 10 to 90. So I've got 10 and I've got 290. So when I go to look at my answer choices, look at that. Those are those ordered pairs that are happening. Oh, look at this. We can already cross out some of these ordered pairs because these numbers 10 and 0 here are what kind of values? Hopefully you've said they're x values, and x values do not belong in the numerator. So it cannot be b because that statement is never going to be correct. Blah. All right, let's keep going. This looks like the same situation here. Those are x values in the numerator. That is bad, 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 bad. Okay, so basically we just need to know which one has a greater rate of change. Those are the ordered pairs. So let's keep figuring this out here. So we're looking at Sasha. So we've got 290 minus 170 over 10 minus 0. So that's still over 10, and then 290 minus 170 is going to give us 120, and then 120 over 10 is going to give us 12. So for Sasha, we have 12. So that's our rate of change. So Natalia, we have 0, 190, and then for I guess they give us the information about 10, so let's do 10, 290, and that's going to be 290 minus 190 over 10 minus 0. That's 100 over why do I keep writing 10 over 10? So that means that, Natalia's is 10. So let's go look here. It says the rate of change of Sasha's account balance is greater. The rate of change of Natalia's balance account is greater. Well, we already know Sasha's is greater. And sure enough, those are the exact order of pairs we use. 290, 170 over 10 minus 0 is greater than 290 minus 190 over 10 minus 0. Again, you've got a situation where we are comparing two different functions. So the first person is Frank. So Frank's given to you by this equation right here. So for Frank, we know, well, actually, let's look at even what we're looking for. Meters per minute, meters per minute, meters per minute, meters per minute. We all should know we're looking for rate of change. So Frank's rate of change is 85, and we're measuring in meters and minutes. So 85 meters per minute. All right, so Jeffrey, we just need to pull out those ordered pairs and find our slope. So that's going to be 5, 400, and 10, 800. Ooh, press a little button on this pen. 800. So that's going to be 800 minus 400 over 10 minus 5. That's going to give us 400 over 5. Well, 40 divided by 5 is 8. So that's going to give us 80 meters per minute. So first of all, let's think who is going faster. Well, Jeffrey's going 80 meters a minute, Frank's going 85. So Frank is 5 meters per minute faster. So let's go look. Which one's true? Jeffrey walks 5. Nope, Jeffrey's not faster. Jeffrey walks 10 per minute faster. Nope. So Jeffrey walks 5 minutes per meter slower than Frank. That is true, because if Frank is going 5 meters faster than Jeffrey, that means that Jeffrey is going 5 meters slower than Frank. And that is our correct answer. All right, on number 36, let's look at our answer choices. We need to find a rate of change and an initial value. So we need a slope and we need a y-intercept. Y-intercept is so easy to find on a graph, so let's go figure this one out. It is -3. So let's go ahead and eliminate answer choices B and D. Slope here, we're going to count because we have a graph. So let's just remember that anytime we're dealing with slope, it's always y over x. That's going to be vertical over horizontal on a graph. And it's going uphill, so we already know it's going to be positive. So I'm going to start with this point. I'm going to start by counting up or down. In this case, it's up. I'm going up 2. So my vertical is 2, going over 1, 2, 3, 4. My horizontal here is 4. So when I go to do y over x, it is 2 over 4, which is equivalent to 1/2. So we're looking at answer choice A. All right, number 52 is a great question, but it is really tricky. So listen up. So it is giving us these triangles. It's telling us they're similar, and it wants to know which proportion can be used to show that the slope of E to B, so that's this part here, E to B, is the same as the slope of D to A. All right, so let's go look at some pieces here. So one of the things that we know about slopes is that if they're the same, they're going to have the same rise over run, right? So what we should know here is that if these have the same slope here, that it's going to also have the same slope of this line here, and also, let me change colors for that one, this line here. So basically, I want to prove that the slope from E to D is the same as the slope from B to A. Because if this slope is the same and this slope is the same, then these slopes on the triangle pieces are also going to be the same. So what I'm going to be doing right here is thinking about how I could get the slope of E to D. Well, to get the slope of E to D, I would want the rise over the run, the vertical over the horizontal. Well, the vertical there is EF, and the horizontal there is FD. Well, I would want to prove that that right there was the same as this right here. And if they simplified to the same value, that would mean that they're equal. So I would want to see if that was equal to the vertical there, which is BC over CA. So I'm going to go look at my answer choices, and I'm looking for EF over FD is equal to BC over CA. And it is right there with answer choice A. All right, on this one, you just have to read, and this one's asking us to think about how much her cable television service is going to cost. So it says she pays this fee each month and then this amount for each movie she orders. So X represents the amount of movies she orders and Y represents the total cost each month. So we should have enough experience with these right now to know which one of these represents our slope. Our slope should be attached to some phrase like each or per or something. But if you look here, this is attached and this is also attached to that same word. So let's go ahead and think about our variables here. So our variable is the number of movies she watches. So we know that the rate of change needs to be attached to the variable. So the variable X refers to a number of movies. So I need a number that also refers to a number of movies. Well, in this case, that's 499. So I know that I'm going to have 499 attached to the variable X. Then I also know that she also pays that as her starting fee, so I need to add that value on. And sure enough, I already have one of my answer choices. It's C. even though it's written in that other order, as long as my slope is attached to my variable, I'm good to go. All right, so there's a couple ways to think about this one. First of all, hourly wage, that's the amount per hour, and we know that the phrase per is associated with slope. So really, this is asking us for the slope. You can also eliminate some of the choices by starting here. So his hourly wage is the amount he makes in 1 hour. So he makes that much in 1 hour. So it's a little more than 10. And 20 is, oh no, that's not great. Hold on 1 second. All right, I think a miracle happened and everything's still here. So again, we know that his hourly wage is somewhere like, oh, I have to click this thing again. Is somewhere like right here. So we know it's a little more than 10, but 20 would be all the way up here. So it can't be 10. It can't be 24 because that would be up there. That's not his hourly wage. That's how much he makes for 2 hours. So it's not that. And 54 doesn't make any sense. So we already know that it is answer choice B. Another way to think about that is if he makes $24 for 2 hours, he makes $12 for 1 hour. We could also find the slope, which is what they want us to do. So that would be 224 and 560, which would be 60 minus 24 over 5 minus 2. So that's going to give me a 3 there and a 36 there. And 36 divided by 3 is 12. So again, lots of different ways to recognize that he is getting paid $12 each hour. So this question is a whole lot like one of the ones on the last assessment. So hopefully if you missed it on the last assessment, you watched the video and then surprise, you know how to do it now. But here we go. So it says every time x increases by 1, so that's plus 1 for x, y decreases by 3, so that's negative 3 for y. So it says when x is negative 6, y is negative 3. So that's an ordered pair of negative 6, negative 3. And it says which function models the relationship between x and y. So I look here, I need a slope, and I need a y-intercept. So we should know by now that slope is change in y over change in x. The change in y here is as y decreases by 3, so the change in y is negative 3. The change in x is as x increases by 1, so that's 1. Well, negative 3 divided by 1 is negative 3. So I already know it's not this and it's not this because negative 3 is my slope and it is attached to the variable. Now I need a y-intercept, so I'm going to say y is equal to mx plus b. So my y value that I'm given here is negative 3. So that's negative 3 is equal to my slope, which is negative 3, times my x value, which is negative 9. Nope, that's a 6, which is negative 6 plus b. So that's going to give me negative 3 is equal to a negative times a negative is a positive. So that's 18 plus b. I need to subtract 18 from both sides. And I'm going to get a value of negative 21 for b. So I hope that if you went through this process like you were supposed to and you got that question wrong last time, I hope you got it this time. Because it really is things like really, as x increases by 1, y decreases by 3. That is telling you verbally that the graph would look like y is down 3 and x is over 1. And then y would be down 3 over 1, down 3. So it's telling you about the slope of a line. All right, well, that's it for now. Next thing that'll happen is I actually changed my mind. I think we're going to go into transformations next. So that's translations, rotations, reflections, and dilations. So be on the lookout very soon for a little review of that. And then once we do our little review, then I will post the first little quiz for our first assessment for the next module. Hope this is helping, guys. I know that by now you've seen that there's no such thing as an EOG next this year. But what you need to recognize is that you're all still going to go on to the next level of math. And whether you like it or not, that's happening, and life is going to be so much easier for you if you really engage in this. Most of this stuff, all the stuff that we are talking about, repeats in Math 1. So talk to anyone who had one of us last year as a math teacher at Piedmont. Ask them how easy Math 1 is right now. And they will tell you it's because eighth grade math at Piedmont was so helpful. So please don't disengage with this. Don't be lazy. You have so much to learn, and you can put in the time, and you will be great. So please do that. Don't waste your time. Don't waste my time. I love you all. Talk to you soon. Bye.